Hello, welcome. Continuation of static force analysis, topic of module number 1. We are not learning anything new, we are applying the things whatever we have learned, and basically we are applying what is called as equilibrium conditions, and applying equilibrium conditions to various situations. What we conclude that I have discussed in my previous class. If it is a two-force system, then the two forces must be equal, opposite and collinear. If it is a three-force system, three forces must have a common point and the resultant force must be equal to 0. And like that, I have explained already what is the meaning of that. And regarding force also, I have been speaking, and force in general, it has certain magnitude, it has direction, it also has what is called as line of action. And I want to make it clear what I am going to face in my analysis. I just want to take only that, say, a small thing. Say for example, this is a body, this point I have marked as A, and I have a statement. Force passing through A. There is one force which is going to pass through point A. So immediate question is, what is the magnitude? So at this stage, I don't know the magnitude. I don't know the magnitude, I don't know the direction, I don't know the line of action. Okay, magnitude is not known, direction is not known, line of action is not known. But only thing I know that the force passes through point A. That means this is the point through which the force shall pass through. Okay, how do I represent such a thing in my analysis? I start from this point A and draw a zigzag line this. Meaning is that zigzag line, the line of action is not known, the magnitude is not known, and direction is not known, and I write down what is called as a force F, which is like this. It may be horizontal, it may be vertical, it may be inclined, it may be in any direction, but the force passes through point A. So the meaning is force passing through point A, whose magnitude is not known, whose direction is not known, we are going to represent it something like this. Okay? So similarly, I have another situation. Vertical force passing through B. Okay? So again, I have a body and I have identified point B, and through this point B, the force shall pass through. I have little more information than the previous case. What is that? Magnitude I don't know. The direction I don't know. But I know that it is a vertical force. It is vertical force. It may be vertically upwards or it may be vertically downwards. Therefore, in such case, I start the force starting from B because it passes through B, and I know that it is vertical. I draw a vertical line. So why upwards? You can draw it downwards also, it doesn't matter. And this is the force, what it represents, what is being told there. Okay? So this is the second situation I may come across when I start my analysis. And the third one, horizontal force of 10 kN towards right at B. I have not drawn the body, and let me assume this is the body and this is point B. Okay, so here the magnitude is known. Okay, what about the direction? Towards right, it is horizontal towards right. That means the direction also is known. So when you know the magnitude and you know the direction, okay, so you can easily represent it. Okay, so the force passes through point B, and I know that it is horizontal. Okay, you draw horizontal line, it doesn't matter, you draw this side also. Yes, you draw it. And it says it has the direction towards right, and therefore put an arrow. Okay, if the direction is known, then we shall put the arrow. Okay, if the direction is not known, then we represent it only by the line of action, that is by drawing only line. So this is how we represent this. I hope it's clear, and this is going to be very useful and we are going to use it. Okay, this is nothing new. And coming to the next one, what is called as, okay, so this is something. Number 3, what I call it, this is something like a table. You have a table or ground, you can say, and on that there are two bodies, two bricks like heavy stones, they have been kept one over the other. Okay, this I call it as body number 2 and this I call it as body number 1. So I have 3 bodies here, body 1, body 2, body 3. Okay, now I would like to draw what is called as what is meant by free body diagram. Go back to the free body diagram which I described or defined in the previous case. What is that? Isolate a body. Okay, isolate one body from what? From its neighbors. From its neighbors and show all the forces that are acting. Okay, now here I have the option of drawing what? I can show draw the free body diagram of 1, draw the free body diagram of 2, okay, and I can show it. Of course, if you say you can draw the free body diagram of this 3 table and then you consider the ground also. The table has to be kept on ground, no? And if you say that the ground also, if this is the ground, okay, so then you can draw the free body diagram of 3 also. But we never go for the free body diagram of the ground, that is not required. Okay, you have so many forces and which you don't know also, and therefore we never try that. You can draw the free body diagram of 1, you can draw the free body diagram of 2, and you can draw the free body diagram of 3, and let me assume that W3 is the weight of the table or body number 3. Okay, now I would like to draw the free body diagram of 1. So draw the free body diagram of 1. What is that? Isolate body number 1 from its neighbors. Who are the neighbors of 1? Who are the neighbors of 1? Only W2, body number 2. Body number 2 is the adjacent member of 1, and therefore if I want to draw the free body diagram of 1, okay, this is the free body diagram of 1. Yes, I have isolated it from what? From 2. You have isolated it from 2. Okay, just you have isolated doesn't mean that. Okay, so when you have kept it 1 over the 2, body number 1 over 2, okay, so there is the effect of 1 on 2. There is the effect of 1 on 2, that way W1 is acting on 2. At the same time, there is the effect of 2 on 1. Okay, this is what we call it as the reaction. The effect of 2 on 1 is the reaction, the effect of 1 on 2 is action. And according to Newton's second law, action and reactions are equal and opposite. Okay, so now, so I have isolated body number 1 and show the action or show the effect. What are the forces that are acting? So I know that the weight of this will be acting vertically downwards. So this is what is W1. This is W1. This is like the external force. So now there is a effect from 2 acting on 1. Okay, so that is what? In what direction it will be? Since it has to remain in equilibrium state, it is already there, and therefore this force must be in the upward direction, and there are only 2 forces, they must be equal, opposite and collinear, and this I call it as R, or I shall call it as F from what? Okay, F from body number 2. I shall call it as F2 and 1. Okay, this is how I represent. Please remember what is the first suffix? First suffix from what body? And the second suffix shall indicate on what body. This is what is the meaning of F21. Please remember, this is the reaction force from 2 acting on 1. Okay, similarly, if I draw the free body diagram of only 2, okay, now isolate body number 2. So this is body number 2. It has to be isolated from 1 acting on 2. Okay, there is a force acting on. Okay, this is what is F1 2. The force, this is a force due to what? Due to 1. Acting on what? This is 2. So how much is this? Please remember F1 2 and F2 1. The effect of 2 on 1 is the same as the effect of 1 on 2. They are exactly opposite. F2 1 and F1 2 are exactly equal and opposite. This is F1 2. Then what is there? Then I also have what is called as W2. the weight of this body. Then there is a force, what is called as the force. Force from what? You have isolated it at this surface from 3. So therefore F3 acting on what? That is 2. F3 2. So therefore you can write F12 plus W2 is equal to F32. And what is F12? Or you can say here F21 is equal to W1. And what is the relationship between F21 and F12? F21 and F12, they have the same magnitude but exactly opposite directions. This is what? Okay, on the same lines we can extend it for 3. This is what is the meaning here. I am going to use the term Fij, the force from link number I. The force from link number I acting on link number J. Similarly, I may use what is called as Fji. What is that? Force from link number J. Force from link number J acting on link number I. And what is the relationship between the two? Fij is exactly equal to minus Fji. Okay, this minus sign tells that these two forces are exactly opposite direction. Okay, the meaning of minus sign is just to tell that these two forces are exactly opposite. And this is equal to this, that means the magnitude of this force is equal to the magnitude of this force. Okay, I hope you understand the notations, all this. So with all this, now we are ready. I hope you also have your tools ready. The drawing tools are ready. Okay, so the problem is already with you. I hope you have copied it. And we shall read it together. And we shall also make an attempt to solve it. Please remember, I shall not solve it completely. I shall only guide you to solve it. And you have to complete the complete solution procedure. You have to go through and completely do it and get the thing what is asked in the problem. Okay, a very simple problem, and so it may take little more time. As I said, I repeat, this is highly reliable question from the examination point of view. You don't have much variations in the questions. You have standard questions, and only thing is, since it is a graphical method, if you don't have practice, it will take a little more time. So initially it may take more time, but as you practice, you can save time. Okay, there are a couple of theory questions. I just read. You don't have these questions. State the condition for a member to be in equilibrium. In is separate and equilibrium. In equilibrium. Okay, what is that? Number 1. When two forces act. This is nothing but two-force system when it is in a equilibrium state. What is your observation, conclusion? That is what is asked. When three forces act, okay, these two together will carry 4 marks. Only statement. If two-force system, the two forces must be equal, opposite and collinear. Three-force system, all the three forces must have a common point and the resultant force must be equal to 0. That's all. Okay, the problem goes like this, which you already have. A slider crank mechanism is acted upon by a force 2 kilonewton at B as shown in figure. Okay, the figure is given to you. Okay, so OA is 100 millimeter, AB is 450 millimeter. Determine the input torque required on the crank OA for the static equilibrium of the mechanism. Okay, so the figure, whatever is given, I just by freehand I draw it. This is the crank center. Okay, you have what is called as crank. You have what is called as crank pin, and you have connecting rod. Then you have piston. And of course you have piston pin here, and then you have guideways. Okay, You may not have cylinder, you have a piston only, which piston will be moving on the guide base. So you have like this. Okay, the naming, this is O and this is A and this is B. This piston pin is B. Okay, so the link numbers, links have been numbered. The fixed link is number 1 and crank is number 2 and connecting rod is number 3 and this piston or slider is number 4. There are 4 links. And you have been given also this angle. This angle is 120 degrees. Okay. In addition, you also have been given what is called as one OA. OA is 100 mm and AB is 450 mm. And the force 2 kilonewton is like this. This is 2 kilonewton, the force which is subjected to. Okay? And you are asked to find out what is called as the torque. This is the torque which you are want to apply on crank. So that when you apply this 2 kilonewton force, this slider will start moving, and because of that connecting rod also will move, and because of that the crank will also start moving and makes the mechanism in equilibrium. It will not remain in equilibrium state and it will start moving, but I don't want that. So as you feel it here, when you apply this force in this direction, this slider will move this and it will make the crank to rotate in this anti-clockwise direction, and therefore the torque whatever you have to apply must be in clockwise direction. That is why in the diagram the direction of this T, this is being called as T, or you can call it as T2, the torque required on link number 2. How much is required? So this is what is the problem. Okay. So the first step is, what is the first step? What is the first step? Draw the diagram to scale, as it is a graphical method. Please make sure that you draw this diagram to scale. Okay, probably you can choose a scale. A scale is equal to 1 centimeter is equal to say 50 mm. Then you decide to draw it. Please draw this probably at the center of the page, not at the very corner or something like that. Okay, so that you have enough space. Then you draw this. It is quite simple. This is what it is. This is the line of stroke, and measure an angle of 120 degrees. And draw this. How much? This is 100 mm. As per our scale, you are supposed to draw this to 2 centimeters. And then this is what you are calling it as A. And then AB is 450. 450 divided by 50, 9 centimeters. With A as center and 9 centimeter radius, you draw an arc and draw this line. This is your B. And make sure that indicate what are called as the turning pairs at all these points. Never forget that. And then you draw a rectangle like thing which will represent your piston, and this is your diagram. Okay. So before I proceed, I just measure this angle and first for my own reference, okay, which will help me later on. So find out how much is alpha. Okay, this is O, this is A, this is B. I number the links. Link number 1, okay, that is fixed link always first link, fixed link. And link 3 is connecting rod, and link 4 is piston. And show the force acting on it. The force acting on it is 2 kilonewton horizontal towards left. This is acting on link number 4. Please remember, it is acting on link number 4. It is not directly acting on link number 3. Okay? Then because of this, there will be a torque, and this is torque T2, and this I don't know. Okay? I also have to find out its magnitude and also direction. Then only it will be complete. Okay? This is the first step. So this is a given problem, and make use of the given data and draw this diagram, and this diagram is called as configuration diagram. Okay? So first step, what is first step? Choose scale and draw what is called as configuration diagram. Okay, that's what has been completed. Then what is the second step? What is the second step? Draw free body diagrams. Of what? Of link 2, link 3 and link 4. This is what is to be done. This is your second step. Free body diagram of link number 2, link number 3 and link number 4. Okay? So this also has to be to scale and this thing, proportionate, not just proportionate, they have to be to scale only, you have no option. Okay, so now, so I would like to draw for link 2, free body diagram of link 2. So what is the meaning of it? Isolate link number 2. Okay, this is link number 2. You isolate it, you remove it from link number 3 and from link number 1. Okay, so first I shall draw. So how to draw that? Okay, choose a point. Okay, you draw one rough construction line, a horizontal line, a light line. Then you measure 120 degrees. You measure 120 degrees. For this purpose, you want to draw a line parallel to this. That is the idea. Okay, now starting from here, you draw how much length line? 2 centimeter line you draw. So this is your link number 2. And one more information which I have not told yet. The effect of 1 on 2 or 2 on 1. Similarly, the effect of 2 on 3, 3 on 2. So that will be through the center of the turning pair. If you have a turning pair, then it is at the through the center of the turning pair, the effect is transferred from one link on to another. Similarly, if you have a slider crank mechanism or sliding pair, it is perpendicular to the contact surface. Perpendicular to the contact surface, that is how you are going to have the action and reaction. Okay? When I come to that I shall again explain. So right now, okay, so 2, I shall draw what is called as, what are these? Turning pairs. Turning pairs. Okay, so now I have isolated 2 from 1. So therefore 1 shall have some effect on 2. There is a force. What is the name of the force? The force from 1. Acting on what? From 2. There is a force F12. So where does it act? It passes through point. I forgot to name this. I shall name this. This is point O and so this is point A. There is a force F12 which will pass through point O. What is the magnitude? I don't know. What is the direction? I don't know. What is the line of action? That also I don't know. But I know that this F12 passes through O. Therefore, start with that O and draw what is called as a zigzag line, which indicates F12. Okay. Similarly, at point A, okay, you have isolated it from 3 and the same argument. You have the force F, what is that? From link number 3, acting on link number 2. This force is what is called as F32. Please remember, apart from these two forces, it is also subjected to what is called as a torque, which has been, whose direction has been given already. This is what I mean by free body diagram of link number 2. Okay, so now link number 3. link number 3. Draw the free body diagram of link number 3. So again, I choose some point, say this point, let it be equal to B. Okay, I draw a horizontal line here, passing through this point. This is the point B. Okay, I measure how much is this alpha, which you constructed actually and found it out. You know the value of alpha, so you measure that alpha. Then draw a line. How much length line? So the same scale, 9 centimeter line you have to draw. 9 centimeter line. And when you draw it, this is equal to A. This line is supposed to be parallel to this connecting rod, which you have drawn here. This line and this line, they are parallel to each other. Okay? So it may not appear really in my diagram, but when you do it, it has to be, this is parallel to this. Okay? This, you choose this point, draw a horizontal line, measure angle alpha, and draw 9 centimeter line, you get point A. Then again show what are called as, what are this? Turning pairs. Turning pairs. So now, what are the forces that are acting? What are the forces? So at A, you have isolated it from 2. You have isolated it from 2. Therefore, there is an effect of 2 acting on 3. This is link number 3. This is link number 3. Effect of 3 acting on 2. What is that? The force. Effect from 2 acting on 3. This is a force. Okay? Whose magnitude is not known. Whose direction is not known. Line of action is not known. But the only thing what I know is it passes through point A. So therefore start from point A and indicate a zigzag line like this. So on the same lines, okay, at 3, okay, at link 3, at point B, okay, it has been isolated from, it is not from 1, 3 and 4 are connected, 3 and 1 are not connected, 3 and 4, it has been isolated from 4. So therefore, there is the effect of force from 4 acting on 3. So what is the magnitude? Don't know. What is the direction? Don't know. What is the line of action? Don't know. But it passes through this. So this is the force F43. So this is what I call it as the free body diagram. I don't have any couple or moment or torque, anything. Unless here, unlike here, this was acting on it. This was known, which we don't know the magnitude. But here, I don't have anything. You can just see here, either here or here. I don't have any force. So therefore, these are the only two forces that are acting on it. Okay. Then, let me come to what is called as link 4. Link 4. The free body diagram of link 4. Okay. Link 4 is like this. You have what is called as a turning pair here. Okay, so show what are the forces that are acting. External force 2 kilonewton that will pass through the center of this pin. This is 2 kilonewton. We don't have any name. Sometimes it may be referred as P, Q, F, R, anything like that. Okay, so 2 kilonewton. Okay, now because of its isolation from what? From link 3 and also from link 1. This link 4 has been isolated from 2 links. One is from 3, the other one is from link number 1. Okay, from link number 3. Okay, link 3. So therefore there is a force called as F3 acting on link number 4. The force 3, 4. Magnitude don't know, direction we don't know, line of action we don't know, but we know that it passes through the center of the pin. Center of the pin, you have a force, what is called as F3, 4, draw a zigzag. Okay? So between 4 and 1, what is that? Sliding pair. And what is the contact? The contact is like this. The contact is here. And the force between 1 and 4 is going to be perpendicular to the contact surface. The contact is like this, and therefore the force is vertical. And this force that I have to show here, and what is that force? Let me name it first. The force from link number 1. Acting on what? Acting on link number 4. So how does it act? Okay, it is a perpendicular. Okay, it has two perpendicular, and I know that there are three forces, 1, 2 and the third one, and all the three forces must have a common point, and therefore that force also passes through like this. This is of 1, 4. So this is what I mean by the second step. The second step. The free body diagrams, draw free body diagrams of all links 2, 3, 4. Okay, now the third step, where little bit of thinking, analysis is required. Okay, so now I closely observe this. Observe this, and check whether we can think of anything. So whether is there anything on which we can drive and solve it. So here, if I start with probably this T2, I don't know. Apart from this direction, I don't know anything. I don't know this force. I don't know this force. Nothing. It is a 2 force and this thing. So I only think what I know that the two forces must be equal, opposite, and parallel. Nothing more than that. Okay. So no information. Let me move on to link number 3. Link number 3. What is this? Go back to the. So what kind of system? It is a 2-force system. Okay, very good. There are only 2 forces. One force passes through A, the other force passes through B. There are only 2 forces, and it is in an equilibrium state. And what are the conditions? The two forces must be equal, opposite, and collinear. Okay, so this will help me to decide what are the line of actions of F23 and F43. F43 passes through this, F23 passes through this, they have to be collinear. What is the meaning of that? F23 also passes through B, and F43 also passes through A. That means I have got some information about the line of action of F23 and F43. How are they? They have to be along the link 3. Or in other words, F23 is along AB, F43 is also along AB. Therefore, so now I have some hint from link number 3, and therefore this line of action of F23, which I had shown zigzag as if it was unknown, now it is no more unknown, it is along this. This is my F23, and I extend this line. This is my line of action of F43. So I have got some hint, and I am able to find out the line of action of F23 and F43. Okay, so now let me proceed further. So is there any relationship between F43 and F34? F43 and F34. Just check here. Fij and Fji. Okay, Fij, what is that? Fij is exactly equal and opposite to Fji. So therefore, if I know F43, that means F43, I don't know completely, but I only know the line of action of F43. If I know the line of action of F43, do you agree that I know the line of action of F34? Both of them have to be opposite. Therefore, they must have the same line of action. Therefore, if I know F43, I know what? I know the line of action of F34. This is exactly parallel to this. Exactly parallel to this. I know this F34. And just for the sake here, I know what is this. This angle is alpha. Okay. So now here, this is a 3-force system. F34 is one force whose line of action is known. F14 is another force whose line of action is known. And 2 kilonewton is another force whose magnitude, direction, everything is known. So therefore, I start with this. I make use of this. What is that? The three forces must have a common point. Yes, that is already there. The force passes through the center of the pin. This force passes through the center of the pin. This force also passes through the center of the pin. They already have a common point. Then there is another condition. What is that? The sum of all the forces must be equal to 0. Okay, so I shall make use of what is called as force polygon. In fact, it is a triangle. There are only 3 forces of link 3. Link 3 I would like to draw. So before I start, I shall assume scale. Scale is equal to, say, 1 centimeter is equal to 0.5 kilonewton. I have chosen randomly 0.5 kilonewton because I am going to represent 2 kilonewton. So 2 kilonewton, I have to draw a line of length 4 centimeters. Okay, if we choose very high, say 1 centimeter equal to 1 kilonewton, probably 2 centimeters, the diagram may become too small and the error of measurement may lead to some error. So therefore, choose any point. Okay. So now, out of the 3 forces, I choose any one force to draw. This is my starting point. I represent it as O. Okay. At the starting point, draw one of the force. So I don't know F1 for magnitude, F3 for how much length line I have to draw, that I don't know. But I have information about 2 kilonewton. 2 kilonewton divided by 0.5, so that becomes 4 centimeters. So I have to draw a line of length 4 centimeters starting from here, whether towards right or towards left. It is towards left, and draw a line of length 4 centimeters. Okay, this is a 2 kilonewton force. So let me call this as, say, OA. Huh? Heading. Force polygon of link 4. Yes. This is link number 4. Okay. So 2 kilonewton. You have drawn this force. Now you are left with either 3, 4 or you have 4, 1, 4. Any one of them you can draw. Okay. I shall choose F1, 4. How is it? At point A, draw F14. How much length line? Magnitude is not known, therefore you don't know. What is the direction? Upwards or downwards? That also I don't know. Okay, so therefore I keep it, my options both sides, and therefore I draw it like this. Indefinite length line. Indefinite. But at point A. Okay, this F14 also has been represented. Now I am left with only one force, and I know that the resultant has to be 0. Resultant has to be 0. What is the meaning of resultant must be 0? If this is the first force, then the second force, at the tip of the second force, draw the third force. The third force must end at my starting point. The third force must end at the starting point, then only the resultant will be 0. If the third force ends somewhere else, then the resultant will not be 0. So therefore, I know that the third force is going to end here. So what is the line of action of this? It is like this. So therefore, at this point, we measure alpha and draw a line and draw this. Okay, now the force triangle is complete. Again, come back. Which is your starting point? O. Which is your first force? 2 kilonewton. Which is the tip of the first force? This is point A. At the tip of the first force, draw the second force. Which is your second force now? It is this force. What is that force? That is F14. Where does it end? It ends at this point. This is point B. So at the tip of the second force, draw the third force. This is your third force. This is your direction. So therefore, F14 is upwards, F34 is like this. So how much is F34? You measure this BO. How many centimeters? BO centimeters. Multiplied by the scale of the diagram, that is 0.5. That will give you what is called as F34. So now what is known? F34 is known. Similarly, if you are also asked to find out how much is F14, AB, measure how many centimeters, multiplied by 0.5 will give you what is F14. Okay, so now I know F34. F34, so many kilonewton, that I know. F34 is known. Do I know F43? F34 and F43 have same magnitude, exactly opposite direction. If F34 is like this, F43 is like this. If F43 is like this, then F23 is like this. F43 and F23 are equal, opposite and collinear. Therefore, F23 is like this. If F23 is like this, then you know F32? F23 and F32, they are like this. Fij is equal to minus Fji, and therefore, so whatever is this line now, at point A, draw a line parallel to that. This is nothing but if you draw this is what is angle alpha. That is why I asked you to measure it every now and then. So now, what is this? F32. It is not only the magnitude, you also know the direction. You know the magnitude, yes or no? Because you know F34 magnitude. F34 magnitude is same as F43 magnitude. F43 magnitude is same as F23 magnitude. F23 magnitude is same as F32. Got it? So now this F32 is not only the magnitude, line of action, direction, you also know magnitude. Okay? Now, I am making use of the earlier discussion, two force and torque. The two forces must be parallel to each other. So therefore, F12 is also, extend this, parallel to it. This is what is your F12. This is F12. And find out what is the perpendicular distance between them. You have drawn it graphically, you measure it. This measure multiplied by the scale. 1 centimeter is equal to 50 mm. This is so many centimeters. If you call this as X. X so many millimeter, you get so many centimeters. Multiplied by 50, that will give you millimeter. Okay? So this distance multiplied by this force, that will give you the couple. So these two, what is the direction of this F12? If F32 is like this, F12 is like this. These two together will form a couple like this. Therefore, you have to apply the torque like this. So F32 multiplied by X is equal to T2. Okay? So here, if you just look at the diagram, you don't know from where we started. You need to go through the entire thing again. I want you to really do it and know. I want to know what is your answer. Since it is a graphical method, your friends may have slightly different answer. So about 10% of variation is normally permitted with the exact answer, and therefore you don't have to worry about the exact unique answer. Okay? Your answer and your friend's answers may slightly vary. Don't worry about it. I want you to really go through. Please don't postpone it. Okay? If you think you have understood, do it today only and understand, so that all our analysis are going to be very, very similar to this. Okay? So I am not going to do too many problems. You have to do it, and all the best. Thank you.